Hello there. Today is day 8 of me trying to learn how to code. And today my focus was to get better at making functions. My first challenge was to just make a simple function that calculated the amount of cans I needed to paint my wall. I did have some instructions here to the left. Oh, sorry. So I knew what I had to do for how the calculation is made, I guess. So here, if we look at my function, it's just super easy. It's the number of cans equals map seal. Let's see here. Wait. Oh, no, that's true. Okay. This equation calculates the amount of cans I need. Let's ignore map seal from the beginning. It takes height times width and divide it by the cover. Here, in the stuff I didn't have to, that's the code I should change. I import the different values. I import the test height and the test width, and the coverage is already set. So it just followed the basic simple calculations from the instructions. What MathSeal does is to round up every time. So if I get 1.3 cans, it should be 2 cans, because you can't buy 1 can and be like, oh yeah, I need to buy 1.3 of that can. Doesn't really work. But yeah, let's say the height of the wall is 3 meters and width are 5. Then I need 3 cans of paint. So that was my first challenge. It was pretty easy and easy to understand. So this was just a quick way to learn about importing parameters, having more parameters in a function. So, and using arguments to import them into the parameters. So now we get to the next challenge. It was the prime number. I've always had a hard time with calculating prime numbers. For the hard stuff. It took me a while, but I did manage to make it. So when we start this code, I check at the rate line the number. So let's say 73, which I know is a prime number. It's a prime number. And we can do a run again. And then 75, which is not a prime number. Yes. So how my code works is I use the factor system for let's see if I can have print here. Print total factors. Print total factors. Let's run this again. 75. Oh, that's not where I want it. It's here. No, wait. I'm gonna print I. Print I. Run. 75. Okay, here I can see. So 75 is divisible by all these numbers. And then I just added them up in the end, which is this value, 124. So if I instead take 73, it's just divisible by 1 and 73, which this calculation does. So every time a number between 1 to 70, the number I imported, is divisible, and is divisible, and the answer is 0. Like how many times I can fit 1 in 73, 73 times, and there's no number that's access. And if I take 75, all these numbers works to have in the same way. So I can have 25 3 times and it's no value over. But if I take 24, it will be 3 times plus 0 point something times. No, if I take 24, it's 48 plus 60, so it's 68 plus 472, and then so it's gonna be around 3 over instead of being even 0. And so how I knew if it was a prime, it was if the total factor was more than 1 plus 73 to 74. So every time it was a prime number, let's say 7, it's always 1 plus the number I imported. If it's not a prime number, then it's divisible by more than itself and 1. Like 10, it's divisible by 1, 2, 5, 1, 2, and 5. Then the combined number is 18. So that's how I solved the prime calculation. Now if we look at what my teacher did, she did it in a very similar way, but instead of using the factors, she is changed. So see here, teacher, maybe we should just run it. I'm just gonna change here real quick. Number 73. It's a prime number. It works exactly the same way. No, her code also works, but not in the same way. It's not a prime number. So for her, if we look at her range here, she has the same. Or if we look at this section, if number is divisible by I equals 0, because it's the same that I had. She said its prime equals false. So here, this is really smart. She fixed so the range always starts from 2 to the number, because then it can't to the number before the number inserted, because every time you insert a number here in a range, it's always number -1. So if I type in 10, it will be 2 to 9. So why this range is so smart is because every number, of course, is divisible by 1 and itself. Now if we test everything between those values and it's divisible even once, then it's not a prime number. That's the basic rule for it. So this is a lot simpler, but yeah, it's a lot simpler, and she just makes its prime true or its prime false. That's just it. But I'm glad I actually solved it without looking at any solution and stuff. So now we come to the main day thing. It was to make an encoded message and even decode it if you want to. So we can run it. Here, down here, I want to encode a message, be hello. And then I want to shift the letters in hello by maybe, we can just say 1. So hello, so hi will be H will be I, and E will be F, and so on. So we type in 1. So my encoded message is IFMMP. So now if I want to decode again, I can just type Y. The decoded text is hello. If I instead want to decode, then the decrypt, I can just write decode. Oops. Decode. And then I might write the message. Fuck, I should have remembered the one. Let's just say B, C, D, E. So I take these ones, and then I shift it back one number, because that's what I remember the code. Then it's A, B, C, D. So how does this code work? I made 2 functions first, one for decoding, one for encoding. I have 3 parameters, or now I have 2, text and shift. So the first one is I make a list. This list I want to fill up with the new positions, when the shifted position of the letter. So if I have A, B, C, would be, and I shift it by 1, then I want to be B, C, D. So for every position in the text, so for A, I make the new position where it is in the alphabet. Oh no, I change it to where it is in the alphabet. Let's see here. So this, no, sorry. This is the position in the alphabet, because I can use the index function and the value. So if it's A, I use the index A, I know it's in position 0 in the alphabet. Then I make it into new letter. So I use this function. Alphabet is, and I shift the position forward then. So alphabet is the position plus shift in pattern decisions in the parentheses. I think that's the English word. Module by the length of alphabet. So this one, okay, in the beginning, this was just enough. We can just talk about this now. So it changes the position plus the shift. So it goes from being 0 to 1, and then I just add it together and round and round until the number of positions in text is out. So I first go through A and convert it to B. Then we'll go for B and convert it to C. And then we'll go to C and convert it to D. And then I yarn it, and then I have made that code. Then I came to this part in the code. This is a debugging part. Because if I wrote Z or XYZ, the first two letters will work perfectly fine. X will go to Y, Y will go to Z. But Z, well, it's not in the part of the list anymore. So what happens? It should go to A. I want it to go to A. So then here, I switch it up. So len alphabet. So it always gets divided by 28, and the letters that are left over, so here will be 1 over the position, so 2 divided by, oh sorry, the length is 25, so 2 divided by 28, so it will be, so 2 fits 10 times, 12 times, and then it is 1 over, because the 11th time, the 13th time, it's 24 plus 2. So then it goes back to here. So it's 25 and then here. It's kind of weird, but that's how this code works. It's a debugging statement. But yeah, so when I have encoded a word and made it into this weird message, I return it so it can be used in future if and else statements. So here, if I then encoded it, it then prints out the encoded text. But then if I want to decode it like I wrote here, let's rerun here. I want to go hello, type your message, oh sorry, with the encode, hello, shifts it by 1. Now it asks me, do I want to decode your message? And this is where this if statement comes in. So it just uses my decoding function, which I will soon explain. So write yes, and it gets decoded back. So how my decoding function works is exactly the same, almost exactly the same. Just the difference are that it doesn't have a bug, and I just take minus the shift, so it just goes back to where it was. And that's how it won't be debugged. or it won't bug because it's already fixed back. So if it's Z and I plus 2 to B, it will just go -2 back to C. Simple as that. So that was what I had time with today, and tomorrow I will continue with this cipher or this decode encode program. Hopefully finish it, because it took me a long time to figure all this out. A very long time actually, where I just spin off on, I fix something and then I spin off and do it more, and it works out, but I did it in more complicated ways and so on and so on. But in the end, perseverance, always fix it. So thank you for me, and hopefully see you tomorrow. Have a good day.